Earlier we have seen row transformation, but now we're gonna see e-column transformation. Again, these are the three rules which we're gonna use. I've already discussed. And for a 2 cross 2 matrix, we have a magic pattern to find the inverse. So what is it is? First, convert A11 element. Next, convert A12. Next, A22, and last A21. This is the magic pattern we're gonna follow to find A inverse. And similarly for 3 cross 3, we also have a magic pattern to follow. First A11, next A12, next A13, but now it's A22, A23, A33, A32, A31, and last A21. So this is something kind of like this. So this is the magic pattern we need to follow to find the A inverse of order 3 cross 3. Now let's take an example of order 2 cross 2 and let's find the inverse of it. Now this is an example of A matrix of order 2 cross 2. So first to find the inverse, we need to find the determinant of A. So which is nothing but 6 minus 6, which is 0. Therefore, A inverse doesn't exist. Now, this is also again different example of order 2 cross 2. So let's first find out the determinant of A, which is minus 4 plus 6, that is 2, which is not equal to 0. Therefore, A inverse exists. So to find out the A inverse by using E-column transformation, this is a kind of magic pattern we're gonna follow. The first step we need to write it as A is equal to A into I. But in row transformation, we have written something like A is equal to I into A. But here we will interchange this. And finally, when we will convert this as A changes to I and A remains the same and I changes to B. So from here, we can get A inverse is equal to B. The first step we're going to write here is A is equal to A into I. Our first step is to convert this 2 entry as 1. So by using column transformation, how can we do this? Like C1 changes as C1 by 2. When we do this, the element 2 changes as 2 by 2, which is 1, and this element 1 changes as 1 by 2. Half. It 2 changes as 1 and 1 changes as half, and column 2 elements remain as it is equal to A into this changes as 1 by 2, 0, and 0 and 1. Now, next step is to convert this element as 0. So by using column transformation, we can write it as C2 changes as C2 plus 6 times of C1. When we do it, minus 6 changes to minus 6 plus 6 times of its corresponding C1 element, that is 1. It becomes 0. Similarly, minus 2 element changes as minus 2 plus 6 times of half, which becomes 1. C1 elements remain as it is, and minus 6 changes as 0, minus 2 changes as 1 is equal to A into C1 elements remain as it is, just C2 elements changes as 3 and 1. Now our next step is to convert this as 1, but it is already as 1. Next, we need to convert this half as 0. So how to do this? Column 1 changes to column 1 minus of half into column 2. Because when we do this, half changes to half minus of half into its corresponding column 2 element, that is 1. This one becomes 0. And similarly, this column 1 element remain as it is. 1 minus half into 0, which is 1. Column 1 elements changes as 1 and 0, and column 2 elements remain as it is equal to a into this half minus 3 by 2, that is minus 1. It remains same 3, and 0 minus half, that is half, and 1. So now it is in the form of I, A, and this is some B matrix. From here, we can write it as A inverse is equal to B. Therefore, A inverse is minus 1, 3, minus half, and 1. This is the required A inverse for this question.